Um, Hello, good afternoon, everybody. Welcome to Code Without Barriers Hackathon problem statement sharing session on reporting for PCAP files containing exchange trading data by Barclays. Today, we have Joanne and Prachi, mentors from Barclays, who will take us and they give us a deep dive on the problem statement. Over to you, Prachi and Joanne.
Thank you. Thank you, sir. John, you wanna go ahead?
Yeah,
Let
can
me
you
share
share
my,
the slides? Yeah.
sure. Okay.
Hello everyone. My name is Juan. Today, Prachi and me will be sharing our problem statement on behalf of Barclays. Let me introduce myself a little bit. I am the Vice President as Software Developer in Barclays Singapore. My team delivers ultra-low latency solution for our clients to trade across different markets in APAC. Prior to joining Barclays, I worked as a digital ASIC engineer. I had 10 years experience in semicon industry. Uh,
Okay.
so,
Yeah,
Raji, can you introduce yourself?
yeah,
Yeah.
sure. Hi, everyone. My name is Prachi Gaikwad. I am the Assistant Vice President in Barclays, Hong Kong, as a trade floor analyst, and my team delivers the support for the low latency applications in quantitative prime services. And I have an experience of 10 years in Barclays. And prior to Hong Kong, I was in Pune, and it's been 2 years I am in Hong Kong. So yeah, so I have the throughout experience in the production support team. Yeah, thank you. Um, so yeah, we'll go to the problem statements. I'll go to the next slide where we are sharing. So basically, our problem statement is reporting for the PCAP files, which is called as packet capture files containing the exchange trading data. We would be explaining four parts of it. First would be the TCP/IP packets. Um, Second would be the examples of PCAP or packet capture analysis. Third part will be the exchange protocols. So we'll be explaining the exchange protocols we are using. The fourth will be the tools and resources, how we are doing it in a current situations. So yeah, so over to you, Joanne, for explaining the um, TCP/IP packets.
Okay. So before we get started, let me have an introduction on some basic concepts. First of all, we need to understand what is a TCP/IP protocol. The full name of TCP/IP protocol is a Transmission Control Protocol and Internet Protocol. TCP is a communication standard. It specifies how data is exchanged over the network by providing the end-to-end communication. So it is connection-oriented protocol. The connection between servers have to be established before sending any data. There are many applications such as emails, FTP, and etc. So our equity trading platform is also based on the TCP protocol. So the TCP packet format must be understood in order to analyze and resolve network communication issues. Here we can see in the slides, this is the basic structure, typical data of the TCP packet. It contains Ethernet header, IP header, TCP header, and also TCP body data, which includes some application payload, such as exchange trading data in fixed or each protocol. So for the Ethernet header, it has the format starting with the preamble, which allow the sender and the receiver to establish bit synchronization. It also contains MAC address of source and destination servers, as well as some data and the CRC field. Okay. Can you move to the next page? So in this slide, we can see the details and the fields of IP header and the TCP header. Due to our limited time, only some of the fields will be explained here, such as the checksum in TCP header, TCP flags, and offset. So my first question is, how is TCP checksum calculated? The TCP checksum is calculated by including the pseudo IP header, TCP header, and the TCP body data. We call the pseudo header because it's not the entire IP header, but it's only part of the IP header. We know that when the packets moving along the network, they are continuous changing. So we have an important concept here to note is we only use a part of the IP header which don't change as the packet moves in the network. Second question is, how does the TCP checksum work? So when the data is sent in a TCP segment, the sender calculates a checksum value. This value would be included in the segment. So on the receiver side, when it receives the TCP packet, the receiver need to recalculate the checksum and compare with the original checksum coming along with the segment. If they do not match, it means that there was a transmission error, so the packet need to be discarded or retransmitted. Okay, this is about the checksum. So second thing I want to explain is the TCP flags. As you can see, there are some typical TCP flags. The entire TCP flag is a 1 byte field in the header. So here, for the common used TCP flag, A stands for ACK. So it means the acknowledging number is valid. P for push, to request for push. R for reset, to reset the connection. S for sync, to synchronize sequence numbers. F for fin, to terminate the connection. Okay, so this is about the common used TCP flags. ACK, push, reset, syn, and fin. So the last concept is the offset in TCP header. So the field specifies the size of the TCP header. It shows the number of 32-bit words in the header. Minimum value is 5. So to get the byte count, we need to multiply by 4. Okay. So we can move to the next page. So after we have the basic understanding on the TCP packet, TCP IP protocol, how does those fields look like? Now I'm going to talk about the TCP three-way handshake. So the TCP three-way handshake is a fundamental process that establishes a reliable connection between two devices over a TCP IP network. It involves 3 steps: syn, ACK, and ACK. Syn stands for synchronize, ACK stands for acknowledge. So during the handshake, the client and the server exchange initial sequence numbers and confirm the connection establishment. In the first step, the client wants to establish a connection with a server, and then the server responds to the client request with syn ACK. So in the final part of client acknowledges the response of the server, and they both establish a reliable connection. Afterwards, they will start the actual data transfer. Uh, these are fundamental knowledges for us to proceed with PCAP analysis. We just quickly went through those basics. And then Prachi will be giving 3 examples to understand how we do the PCAP analysis. Yeah, so then we can move to the next page.
Okay, thanks, Joan. So here we are using the first example for PCAP analysis. So as Joan explained, the wrong GCP checksum. So basically here we are explaining that when the client send the wrong TCP checksum, we get the issues. So as a if a new order packet was sent with the wrong TCP checksum from the client side, right? So the uh, uh, the the checksum is a value which is calculated from the TCP header and a payload data to verify the data integrity. If the and this message goes to the exchange, right? So if there is any the TCP the checksum which is being sent from the client, it doesn't matches at the exchange side, then exchange will drop the packet and it will give you the duplicate ACK saying we need the retransmission of the data. So I will explain this particular picture with the example. I will, okay. So from this is the uh, PCAP packet captures, which we use to analyze the data. So if you see, the first column is the time when the packets were exchanged. If you see, the second column is the source IP, which you consider as a client IP. Then we have something called as source port, which is the client port. And then we have the destination, which is destination IP, which is the exchange IP. Exchange IP, and please do keep in mind that since we are this example is very specific to the Tokyo Stock Exchange. So here we are using the port as a destination port as 10001. So from this you can recognize whether the message has been sent from the exchange or from the client. So if you see here, so this is the destination port. Next is the sequence number on which the transactions, the exchange of packet data happens. So we will get the sequence number and we will get the next sequence number as well on which the exchange should send the packet. Um, this is the acknowledgement and then is the length of the payload. Payload is something which contains the data, exchange data or client data,
Yeah,
which
the
is the
payload. Yeah,
hmm,
so the payload here, Prachi mentioned actually was the TCP body part. I mentioned it in the previous slides.
that's right.
Okay.
Yeah. Thank you. Thanks, Sean. So this info, or it is called payload basically. So if you see this whole data which we see here is a payload which contains the client data or exchange data which needs to be which contains data basically, right? Here, as per this particular example, the client is sending, if you see this, the client, the black line, the client is sending a wrong TCP checksum or incorrect TCP checksum, due to which the exchange is asking for the retransmission. So if you see, first is the black line. Okay, here a client is sending the wrong TCP checksum. If you see the sixth line, right here, exchange is sending. How do we know this exchange is coming? If you see the port, this message is coming in from the exchange side, which is in purple, and it is sending the duplicate ACK asking for the message retransmission, and that's how the retransmission happening at the client flow, which we want to avoid basically, right? So we've for this example, we want to figure out. So what we are expecting here, um, eh, sorry, right. So if you see, we are expecting our AI model to generate the report where it shows the source server IP and the port with the sequence number, which is sending the wrong TCP checksum, and also the destination server and IP, which has dropped the packet, which is also you can say the responded with a duplicate ACK, which is doing the TCP transmission, retransmission on that flow. So we need a report which will give us the source port, source IP, and the sequence number, and the reason basically that what has happened and why the retransmission flow is happening.
Yeah,
So
so Prachi just gave you the example of the actual case, how we do the analysis on those PCAP packets. And then when we see some abnormal condition, just like the checksum error happen for one packet, and and then causing the retransmission in the subsequent flow, right? So normally we do the manual analysis, but if you can develop a solution to check this kind of abnormal condition, the errors in the TCP packet, and then generate a report, that would be an ideal case. And then for the report, you can, we already give the example, right? Normally, how do we give the report, and what kind of format the report should be look like? So you can take the case, and then you just provide a solution, use the AI model, and see whether it can get a similar report or similar result. Yeah.
yeah, right. So this is the screenshot. I would like to give an example. This is the Wireshark which we use to manually check the issue. So here is the recent example. If you see the first line, this is the message which is coming from the client stream. And if you see the third line, it is the acknowledgement from the exchange side, because the port is 1001. If you see the black line, it is showing that we are getting the ACK, duplicated ACK from the exchange side, if you see, which is asking us or client to send the retransmit the packet again. And that's what we want to identify in the example. Now, these I have shown example for the one session. We could have the multiple sessions as well. So we need the AI model to be developed so that it can basically identify all the sessions. Like if it is having a multiple session, and multiple session is having this retransmission issues, TCP check retransmission issue. So AI model should be able to identify for all the sessions in in this particular flow, to see if there are any issues or any retransmission flows, and to generate the report for each of the session. So if you see here, there are two sessions. It's with the IP 127.0.2, similarly dot 127.0.4. So similarly, you can, so this is an example which I'm trying to show, just to update that it can happen on the multiple sessions as well.
Mm.
Uh, okay, I will go with the next slide. So for the second PCAP analysis example, which shows the bogus TCP length bogus TCP header length. What does it mean? Let me increase the font. So here, if you see, um, we are seeing the client messages in light purple and the exchange messages in the dark purple lines. So what happens that sometimes client send the messages with the uh, header length as 0. So the header length should never be 0. If you see, if the exchange sees sorry, it's not exchange. So basically, if you see that the in the fifth row, here the header length is 0 bytes. Here, it should be, as Juan said in the previous slide, that it should be 5 and needs to be multiplied by 20 and needs to be multiplied by 4. So here what's happening that on the fifth row, client is sending the header with 0 bytes, which is being detected by the network side. And as per the since it is excluding the it's not having the header length, so uh, it will again ask for the retransmission from the for the particular packet. So here also, if you see here on the right side, the header length, it shows 0 over here. Uh, but what we need is minimum value of 5, which needs to be multiplied by the 4 to get the byte count, which is 20. But here we are getting the 0, which is actually not the proper message. And that's why, due to the network condition, the packet will be dropped and ask for the retransmission. So here we are expecting this report. If we are expecting the report like this uh, from the AI model, which will show the TCP header length with the source IP and the port with the sequence number, which is sending the bogus TCP header length. And for the packet, and also it should give the reason that why it is being rejected or dropped, because it should have the minimum value of 5, but the actual value the source server sent was 0. And then as a result, the retransmission occurred for the subsequent packet. So this kind of report we needed, and maybe a better report where we need the actual source IP or client IP and port and the sequence number with the actual reason why the packet has been dropped. So I will show the actual how it looks in the PCAP file. So here, if we compare the first packet, which is the client, or source message. If you see here, the header length should be 20 bytes. Or here, if you if you see here on the right side, it shows 50. It shows 5, which needs to be multiplied by 4, which actually shows the length as 20 bytes. So this is the good packet which is being sent from the client. Now we will see the bad packet. Here, if you see, the header length is shown as 0 byte. If you click over here on the right side, here I see the header length is 0, which should be 5, minimum 5. So this is how it is, and this is how it is being shown, it is being seen in the actual PCAP. Now I will go to the third example. Here, my third example is the session disconnect. So we have to identify how the session disconnect means the client session or the source session get disconnect when there is a reset or fin packet sent from the exchange from the our system. So I will show the example. So here, let me just keep it over here a little. So from this particular example, what we see in the there are two sessions basically. The session with the source port here, the client session is with the source port 44 11111, and there is one more client session which is 40,000. Here we please note that here the destination port or the exchange port is different. It's not 10001, it's 11410. It's just to make you understand that which one is the exchange packet and which one is the client packet, right? So here, if you see, there are two sessions being configured. One is with the port 40,000 and one is with the port 41111. Here, what is happening? So basically, this session with the 40,000 is not configured at our system side, at our end or at the Barclays end. And but the packet with the fifth row, which is the actual client session, it has been configured at our end. So we are able to allow them to connect, but we won't be able to allow the other session, which is having a port 40,000 on our system. So what we will do, we will drop this packet, right? But what is happening? That what we have identified, that if there are any sessions which are not configured at end, uh, this should be we should be sending, our system should be sending the reset and fin packet to the session which is not allowed to our system. But here what was happening, since there were two sessions, our system sent the reset and fin packet to the active session and disconnected the actual active session and not the bogus session. So this was the example which I have seen, seen in at our end. So here, what we are expecting from this particular example. So here, if you see, there are two sessions coming in the incoming flow. So this is the report which we are expecting here. The two sessions with the port 41111 and the second session with the port 40,000. Here what it says, that session 2 was not configured, so it was not allowed to go through the system, and it should have been dropped and received the reset and fin packet to disconnect it. So the fin, as Juan explained in earlier slide, if we do not identify any session, our system send the reset and fin packet to drop that particular session. But here, what issue has been detected, that the sync packet has been sent to the first session and not the second, due to which our first session with the port 4111 got dropped and not the bogus session. So this is how we would like to our AI model can help us to generate a report like this.
Thank you, Prachi, for giving the three examples. It's very detailed explanation. Okay,
Thank you.
because we don't have enough time, so let's
Sure.
move to the next slide.
Yeah, sure.
So I want to mention a little bit about the TCP body part. So TCP body, so here we give two examples. It could be a fixed protocol message or each protocol message. So fixed protocol is a very common protocol application data used in our trading system. The fixed protocol message represents a sequence of fields whose value are associated with tags. Each message field, including tag and value as a pair, has its unique meaning. Each message is separated by non-printable ASCII characters. And all text and most field values are printable ASCII strings. We can see here 8 is begin string, and then the value is fixed 4.2. 9 stands for body length, and the value is 118. 35 is the message type, and the value is D. D stands for the new order. So we can get the details from the link provided in the slides for the fixed protocol message. And also for each protocol message. First of all, let me give you some background about each protocol message. Each protocol was developed by Nasdaq for transmitting real-time market data. It's optimized for low latency performance. As we already see, the fixed message is transferred in text format, while each message is transferred in binary. So this lead to smaller size compared to fixed messages. And also it occupies less bandwidth over the network. Okay, so for the details of each and fixed, you can check the link provided. Okay, let's move to the last page. Yeah, for the tools and the resources we have. You can use the Olama. So Olama is a open source framework to run large language model locally on your own machine. And it contains some popular models, including Phi by Microsoft, Llama by Meta, and Gamma by Google. We would highly recommend you to use the Phi LLM model by Microsoft. And because just now, Prachi gave you the demonstration with the Wireshark, right? How to do the packet analysis. And Wireshark is the network analyzer that can capture and display network traffic. T-Shark is a terminal-based version of Wireshark, and PyShark is a Python wrapper for T-Shark. So you can use freely any of these tools. So and then so for the final one, there is a demo about how we integrate Olama into the Python script and how we call the LLM model file tree. You can have a look how it works and what kind of output it provides. Okay. Thank you. Thank you everyone for interested in Barclay's problem statement and join us for the session. If you have any queries, you can leave your questions on Discord. I think there has been a channel created for Barclays mentoring. Thank you one more time. And I think this is the end of this session.
Thank you. Thank you so much, Juan and Prachi, for the insightful session. I'm pretty sure that participants have gained the insight and they are now ready to code and build a solution there. So requesting all participants to join the Discord channel so that you get constant updates on the problem statements and what are the next updates of the hackathon. So requesting all to join there. And I think we'll call it a day for the session, and be rest assured for the participants who've missed out on this session, we will be updating this video onto the website so that if any of your peers or any of your friends who are participating in the hack and they could not join, they can still view the entire video, right? So thank you so much again, Prachi and Juan. You have a lovely day ahead. Thank you
Thank
so
you
much, all
so much.
participants.
Thank you.
Yeah,
Thank you.
wish you all the best. Bye-bye.
Okay, bye-bye.